In this module, we're going to go ahead and take a look at the OSPF packet header. Now, we've just completed going through the 5 different OSPF packet types, type 1 through 5, where we looked at the hello packets, the database descriptor packets, link state request, link state update, and then link state acknowledgement packets. Now, one of the things that all of these OSPF packet types have in common is that it's an OSPF header that precedes the packet when we take a look at the Wireshark packet capture. Now, every OSPF packet begins with a 24-byte packet header. So what are those bytes? What does it communicate? Well, it's going to communicate the version, the type, the packet length, the router ID, the area ID. There's going to be a checksum value in there, and we're going to take a look at the single exception. And what do you think that exception? Think about that when we get to that. See if you can figure out what the exception might be when there will not be a checksum value. We're going to talk about authentication type, and then the authentication data, and then just the data, right? So what packet type is it carrying? Is it hello data? Is it going to be a link state update? Is it a link state request, right? So that would be the data portion, and that's going to be the variable portion of the packet length. But again, the header is 24 bytes. So let's go ahead and dive in here to Wireshark, and let's grab ourselves some information. So I'm going to say continue without saving, and you can see we've got all kinds of broadcast activity here. Let's go ahead and on router 1, let's clear our IP OSPF. We'll go from user exec to privilege exec, and we'll say clear IP OSPF proc, and then we'll say yes. And that is definitely going to generate a rich set of data, and there it is. And let's pick off the link state update here, right? So let's double click on this. Let's give ourselves a little more room with which to work. And again, the information contained in the header, this header is on every single OSPF packet type, right? It goes with every single OSPF packet type. And so let's take a look at the header information. In fact, let me go ahead and we're going to collapse down. This would be considered the data, right? All right, let's bring out our drawing tool here. So when we talk about the fields in the OSPF header, we've got the version type, right? So we're running OSPF v2, RFC 2328. If it was version 3, we'd see a 3 here. We've got the message type, right? So that's a 1-byte value, and it is 4. And then we've got the packet length. Now remember, you're probably saying, well, wait a second, you just said it was a 24-byte header. Well, remember, this is reflecting the entire length, right? The entire size of the packet. So it's the header plus the data, right? This variable, I'll just put var, this variable data that's going to go with the OSPF header. Because again, it could be a link state update, it could be a hello packet. So this field will vary, but we can deduce that if the header is 24 bytes and we've got 60 bytes total, then this is going to end up being 36 bytes, right? So then we've got the source OSPF router ID, right? And it's 2.2.2.2. Then we get the area ID. It tells us, is it a stub area, the backbone area? And you can see here that this is an area 0, so it's in the backbone. Then we've got that checksum field that we talked about. And you can see the checksum is correct, making sure that this is a valid packet, that it's not a corrupt header on the OSPF packet. Then we've got the authentication type. We'll talk about these much, much more in depth when we get to authentication. But we've got 3 types. You've got null, plain text, and then cryptographic. Now, sometimes you'll hear people refer to it as MD5, and before 15.4 code, that would have been a correct statement. That you could have said it was null, it was plain text for type 1 is plain text, and then type 2 would have been MD5. But after 15.4 code, that is when OSPF on the Cisco implementation started to support, I shouldn't say SHA-1, I believe SHA-2, sorry, SHA-2, right? So you could use a SHA-256 hash in the SHA-2 family, a SHA-256 hash along with OSPF. And so it's more appropriate right now to just basically say there's 3 types, null, plain text, and then cryptographic. And so, because you can still do MD5, you shouldn't do MD5. If you can avoid it, definitely avoid it. But then you've got the auth data, right? And so this is going to be the hash data that comes through that is then going to be unhashed in between the OSPF routers. And so the final thing we're going to talk about here is this field here, this checksum. So when do you think there would be no checksum needed? Exactly. If we're doing authentication. And so let's check that out, and we'll very quickly set the authentication up, but we want to make sure we look at each of the use cases in turn for when you might see that there's no checksum value there. All right, so let's real quickly here, let's just go into global config, router OSPF, OSPF 1. I'm going to say IP OSPF, message digest, do we get that? Oh, I'm sorry, area 0. I'm thinking I was under the interface. So area 0, authentication, if I could spell properly today here. Authentication, message digest. And then under the interface, FA00, we're going to say IP OSPF, message digest key 1, MD5, and Cisco. Now let's go over and quickly do that same thing over here before the adjacency goes down. So we'll go from user exec to privilege exec into global config, router OSP, and there it is again, OSPF 1, and we're simply going to say area 0, authentication, message digest. Get under the interface, and this is where we're going to put the key, IP OSPF, message digest, key 1, MD5, Cisco. Right, so we're now running authentication between the two routers. Let's make sure, do show IP OSPF neighbor. Let's make sure that that adjacency is up. Over the fast Ethernet interface, it is. We're at 33 seconds, so let's see what we look at now. And you can see that we're good, right? So let's go ahead and we'll pull packet, we'll do a packet capture here with Wireshark again. And again, remember, it can be any OSPF packet. You'll notice I'm not restarting the OSPF process because we should see a hello packet, and lo and behold, there it is within 10 seconds. So let's just pick off that hello packet right there, and let's take a look. So here we are taking a look at the OSPF packet header, that 24 bytes. You can see here that we've got 48 bytes total for the packet length because, again, here is our data. The LLS data, right, that link local signaling data in the hello packet, which is making up 24 bytes, plus our 24-byte packet header. So when we look at this, again, we've got OSPF version 2, type 1 packet, a hello packet, the length, the router ID of the source router, the area. Now, here's where you see checksum, and it's basically all null, right? It's all 0x0000. It's all zeros. There is no checksum. And the reason there's no checksum is because we've got the authentication type. You can see there's our key ID for the cryptographic. There's the data length, the cryptographic key sequence, and then the data, right? So we add in these additional pieces of information, and therefore we no longer need the checksum. So remember that. Remember that you'll see that there is no checksum when authentication is being employed. So no checksum in the OSPF packet header. All right. Well, this is going to wrap up this module on the OSPF packet header. Again, we went over the packet header fields. Every OSPF packet is going to carry that, or going to be preceded by the packet header, right? And then we've got the data or the payload, which is going to be the actual OSPF packet, right? But we've got a header that gives us additional information. And the cryptographic, or I should say the checksum, will be null, or there'll be no checksum in the event that you've got encryption running between your OSPF neighbors. All right. Well, thank you so much for watching, and I hope to see you in the next video.